Same thing, just day 2 with power chain rule. Day 2. So the main premise in these problems is that we're going to be looking at problems where the baby, or in terms of today, we're going to talk about problems where the baby is a power function other than a linear function. So, as a reminder, not all problems are chain rule, are U-substitution. So sometimes we get into this little part piece where we're just like every single problem has to be it. So for example, if I gave you the integral of x cubed plus 1 squared dx, this is a problem where many people will look at and think, I need to do U-substitution on this problem. I see two functions of x in the problem. So while two functions of x, and we got x and x cubed plus 1, this is not a U-sub problem, as the derivative of x cubed plus 1 would be 3x squared. And it's this x squared piece here that's important. We have x. So it doesn't work, because if you did U-substitution with u equals x cubed plus 1, then your baby has to be 1 degree or 1 degree less, which in this case would be x squared. So in this type of problem, we must expand for this problem. So I just want to make sure that you recognize that some of these odd problems here. So this becomes the integral of x times x. If we expand this is x cubed plus 1 times x cubed plus 1 dx, which is x, the integral of x times x to the 6 plus 2x cubed plus 1 dx, which becomes the integral of x to the 7th plus 2x to the 4th plus x dx. All right. Oftentimes, like I said, you don't, when you're doing these types of problems, it's like these will be like multiple choice type of questions. All right. If you look at this and you can recognize I cannot do U-substitution on this problem, you're automatically going to be eliminating two answers because you know two of them will be wrong. Now, let's say you're having trouble expanding and you don't know, you're having, you might feel like you might make a mistake in your expansion. Well, you know that x cubed times x is x to the 7th. So you know that the very first term was going to be x to the 7th. Based on that knowledge alone, you can look at the answers and you can go, oh, one of the answers has a 1/8 x to the 8th. And as a result, and that's the only one that has a 1/8 x to the 8th power, you could recognize that that has to be the answer, since none of the other ones have that. And you're going to have to expand. Boom, you select your answer and you move on. So now this one's just a simple power rule. We get 1/8 x to the 8th plus 2 over 5 x to the 5th plus 1/2 x squared plus c. Now, if you notice how I did this problem a little bit more. This is our third day of doing integration. And so typically I would do the parentheses x to the 8th and then 2 times parentheses 1 over 5. But with problems that become a little bit easier now, and remember x is the same as x to the 1, I'm able to just do it a little bit more cleaner as I do the work. So now that I've gotten that away, let's look at let's look at 2 more examples of U-substitution. All right. So the first one that we're going to integrate is 2x 6x squared minus 8x over 5 parentheses x cubed minus 4x squared plus 1 to the 3rd power. Now this one is very interesting because if I look at this problem, there's a lot of things going on right here. Okay, now we could even put parentheses around here, and you can see that I have 2 functions of x. I have 2 things that have parentheses about them, but I've taken a look at this problem. Remember, these problems have to be able to be done. You're not going to get a problem where there's no answer. Once again, multiple choice. So when you look at this problem, you should feel comfortable in saying, I have to use U-substitution, all right? There is some type of problem with U-substitution. Once again, if you utilize conceptual understandings of what's going to happen with a multiple choice question, you can often make and eliminate different choices. For example, I know the denominator has to be u, so it's kind of like this is like u to the -3. Right? I get that. It's going to be like u to the -3, which would give me like a -1/2 u to the -2. Okay. Now, I also look and I see this 5 and I see some weird things going on here. So most likely it's not going to be a -1/2. So it's something, it's some constant times something to the -2nd power. So when I look at my multiple choice answers, most likely there's only going to be 2 that look like that. Jatasia brought this up last week, and so I'm going to do it for us still. Let's clean this up. Let's try to factor this problem all the way out. Let's try to bring everything up. Let's make it more calculus friendly before we start doing all the other stuff. So I look up at the top, and what do I notice about the top? Can anybody tell me what can be done about the top?
They're both even and they both have x's.
They're both even and they both have x's. Yes. I'm not going to factor out the x's because it would create more than 2 terms with x, but I will factor out that too. So Ariana's saying they both have x's, and so we can factor out an x from the top. Here's the problem with factor out an x. If you factor out an x, then you have an x, parentheses, another x, and then you have a 3rd x type of terms on the bottom. That's a no-no. But she brings out a good point. They're even. So we can bring out a 2. The bottom, sorry, I gotta fix this part. The bottom down here was supposed to be a 2. Bah, that's on me. Please fix this right here. Okay. Over 5 parentheses x cubed minus 2x squared plus 1 cubed dx. Now, when I do this problem, when I clean this up, I got to make sure I do good algebra, all right? So what I'm going to do is when I see the 2 and the 5, so that's a 2/5. So I'm just going to bring that 2/5 outside the integral. I get a 3x squared minus 4x. And then I get a x cubed minus 2x squared plus 1. And that becomes the what power? To the what power?
Oh, you moved it up. So would it be -3?
-3. Perfect. So that's the biggest thing that you have to do. That's the algebra. All right. You can only get better at that by practicing it and making sure and reviewing it and marking over. A lot of individuals are getting a lot of more beneficial help by coming to tutoring and working out these problems, because a lot of it is just the algebra. And it's not that it's not that you're bad at algebra or you don't know how to do the algebra. It's that it just takes practice to kind of feel for when you have to do different types of algebra. It's a big part of this course, right? The process is going to be the same, because now I can do what I normally do. And I go, oh, okay, u is x cubed minus 2x squared plus 1. Hopefully, I don't believe, and based on what I've at least been getting, we don't have a trouble identifying that that's going to be my u, because it's being raised to the -3rd power. My du in this case would be what?
3x to the second power minus 4x.
Close parentheses and dx. And that's nice because, boom, there is where I see that piece right there. So remember, just like last homeworks, all the problems are going to lead to the same place. Now this one, I can't, there's nothing I can factor out, so this one's a different one. If this turned out to be something like 6x squared minus 8x, so I'm not going to change it. But if this was like a 6x squared minus 8x, then I would have said, oh, that's 2, 3x squared minus 4x dx, because this part right here I would have seen up there. So I just want to point that out. Sometimes I've seen a problem happen like that, but this one's nice. I can't do anything to it, so that's my substitution. So now I get 2/5 the integral of what? Remember, all problems will look the same right here. This is like that. When I make it into u's, all my problems will always be u to some power. So what do I get? It'll always become integral of u to some power. So what do I get?
Would it be u to -3?
Yeah.
To the power -3.
Perfect. So they're always going to look like this when you make your u. So after this, it'll always, and at least last night's homework, tonight's homework, tomorrow's homework, this step will always look the same. And that's the one thing that we got to feel comfortable with, at least. And especially these problems where they're always the same, you should be able to do it. And so now I get 2/5 parentheses u to the -2, just like I had said. -1/2. Ooh, those 2's are going to cancel out. Plus c, which gives me -1/5 parentheses, replace my u, x cubed minus 2x squared plus 1 to the -2nd power plus c. Yes, I could rewrite it without the negative power, but that's not our focus right now, and that's what we get. Huh? Do one more example. I got 10 minutes or 9 minutes. We got time for one more. This one is a little bit trickier. This is the integral of square root of x minus 6 to the 4th all over 3 square root of x dx. Now, this one's interesting because when identifying what's going to be u, well, first off, I see two things of x's, but they're both square root of x's. That's a weird one. Well, if you can, once you feel comfortable, or you should kind of know that the derivative of square root of x is 1 over 2 square root of x. So it makes sense that when I have a u that's a square root of x, that I'm going to see a square root of x in the bottom. With that said, when trying to identify what is going to be my u, typically we said we look for things that are in parentheses or things in the denominator that could be also considered parentheses. This has both, but multiple term functions that are in parentheses always take precedence, and it's not that it's a rule. It's more that when trying to figure out how to move forward or how to quickly decide what you got to do, those are good things to note. So I can kind of see that my square root of x minus 6, that piece is going to play my u. But let me clean up the algebra, okay? Before I move forward with anything on this problem, I want to make sure I get my algebra correct. So this is the same thing as that 3 that's on the bottom is really, dividing by 3 is the same thing as multiplying by what?
1/3.
So this is 1/3 the integral. I'm not doing any, this is algebra. No integration, no calculus. No calculus. No calculus. And I'm going to put the parentheses. Square root of x is also known as what?
X to the power of 1/2.
Minus 6 to the power of 4th. And the over x to the over square root of x becomes what?
Parentheses x to the power of negative 1/2.
Yeah, and you don't actually need parentheses here. So it's just one term, so it's x to the negative 1/2 dx. Now, the hardest thing about this problem is rewriting it here. This is the hardest part. And you can only do that by practice and recognition and doing examples. Once you've gotten this, the rest of the problem is pretty straightforward. What is my u?
Would it be x to the power of 1/2 minus 6?
Good. And my du would therefore be?
1/2 x to the power of 3/2?
No.
Wait. E minus 1.
Uh-huh.
Oh, negative 1/2?
Yep. Now remember, the rule is to solve for x. So I had to bring that 1/2 to the other side. What does it become when I move it, when I do the algebra? What does this become?
Would it be would it still be like oh,
So what does it become?
I know the 1/2 cancels out.
So
You
what do
multiply everything by 2.
Yep, so what do I get?
You get 2 du equals, would it be like 2x to the power?
No, the two cancel each other out. So you get x. You're not going to get any constant here. Remember, the goal here for us is always to get this x terms by themselves. Completely factored. So this one was a little different because the other ones you usually got like 2x or something like that, and you divide it by 2 on both sides. But basically, we're multiplying by 2 on both sides. And so that we can get to this part right here. Because also you should recognize I got an x to the negative 1/2. So I'm trying to solve what is x to the negative 1/2 dx. That's basically, or that's what I'm trying to figure out. So now that 2 is going to come out in front. So what I get now, I don't forget that 1/3. I get 2 integral u to the u to the what power?
The power of 4?
Yep, du. So the problem still stayed the same. That is 2/3 parentheses u to the 5th, 1/5 plus c, which gives me 2/15 parentheses x to the 1/2 minus 6 to the 5th power plus c. Yes, you can write that x to the 1/2 and you can rewrite it back as a square root. It that's what we got. So that's just a different problem. It's the same type of concept. It's just feeling it out. You'll see some with one problems with square root of x. I think the other problem that might be a little bit difficult is when you have negatives. So for example, if the baby had like 1 over x squared minus 6, then on the denominator you might see x cubed, and it's the same process. That if you gotta focus on being able to rewrite that algebra and doing the algebra to rewrite it. Once you get here, the problem should at minimum feel like the other problems. Okay? That's all I have for you today. Your homework is online. Tutoring today, of course, at 2:31 still. I'll make sure I'm logged in as well for Dr. Akers. That's what I have for you. I will see you tomorrow. Same time, same place.
All right, sir.
Take care. Bye.